Hello and welcome to this Q&A session with Inna Braverman, CEO and founder of EcoWave Power. Welcome.
Thank you.
How are you?
Very well. How are you?
Oh, I'm fine. You have invited shareholders to send us their questions, and we will get into them right away. We have summarized them under three sessions. One is about technology, one is about current projects, and the last one is about business and commercialization. So we'll start. Firstly, there are a few questions about the origin of the technology. Can you tell us about the history of the technology?
Of course. So EcoWave Power has developed the technology independently. The company was established in 2011. The idea behind the technology is my idea together with David Leb, the co-founder of EcoWave Power, who was also a serial entrepreneur. We started the development of the technology in the Hydromechanical Institute. That's where we did our first wave pool testing. When we finished this testing, we moved to real condition testing in the port of Jaffa, where our pilot station worked since 2014 till 2020. Currently, we're expanding the Jaffa Port Power Station together with the EDF Renewables, which is a subsidiary of EDF, the French national electrical company. And we also have our grid-connected power station in Gibraltar, operating since 2016. The technology has 17 patents and patents pending, including patents in Israel, in the European Union, and the United States. And the technology is considered very unique. It's just recently appeared in a report by IRENA, the International Renewable Energy Agency. Also, we just received today, actually, a new study that was made by CEREMA, a governmental research agency in France, that also determined that our type of technology is unique and is actually expected to be the most cost-efficient technology.
What is the status of the technology today? Is it fully developed or does it need further developments?
So the technology today is in a very high readiness level. We were able to overcome some major challenges that have been occurring to wave energy developers before us. The main challenges really of the wave energy technology so far was the price of the systems, which we overcame with our Gibraltar power station. We built it for a price of $450,000, which is of course a very, very low price in comparison to other renewable energy, wave energy developers. Another concern with the wave energy industry was the breakability of the systems, because extreme wave height cause extreme loads to the equipment, and a lot of the devices like Pelamis or Ocean Links or Wello just recently have sank due to the extreme weather. This we solved by having a patented storm protection mechanism. When the waves are too high for the system to handle, the floaters automatically lift above the water level and they stay in the upward position until the storm passes, similar to wind turbines that stop turning when the wind is actually too strong. We also proved that we can insure the technology in Gibraltar and in Israel, and that we don't create any new presence on the ocean floor and don't change the ecological balance. Thus, we're 100% environmentally friendly. So the technology has kind of overcame the main challenges of the wave energy industry. And now we're moving to the next step, which is building the first commercial scale power station, which is something that has not been achieved in the wave energy industry yet.
In your presentation from ABG's seminar, you showed a slide comparing current projects. In Gibraltar, you have 8 floaters with a capacity of 100 kilowatts. And in Israel, you have 10 floaters, larger floaters, and still the capacity remains the same. Why doesn't the capacity increase with the number and the larger floaters?
So usually it does increase. The more floaters you put and the larger the size of the floater, the more energy you generate. The reason for choosing relatively large floaters for the Mediterranean Sea, which is the sea here in Israel, is the fact that our EWP EDF project that we're doing now in Jaffa Port is kind of our preparation for our first commercial scale power station in Portugal. So basically the floater sizes that we're using here are the same floater sizes that we're planning to use for our first 1 megawatt in Portugal. Thus, we're removing the risk of scalability of the system. So we're actually using larger floaters than we would usually use in the marine conditions that are prevailing in the Mediterranean Sea, because we use it as preparation for our next project.
Your niche is to install wave energy converters on onshore structures. Considering the waves are larger heights at sea, can you imagine offshore installations of your technology? And are there advantages of being an onshore company?
So first of all, we really chose the onshore because we believe that the wave energy industry is just starting its commercialization, and we believe that we should start where it's safe, where it's cost efficient, where it's easy to construct and it's easier to maintain the technology. If we look, for example, at a comparable industry, if we look at the wind industry, we see that it took 100 years of experience until the first offshore wind farm has been built. So we're learning from industries that have good experience and that did it successfully before. And we think that really the starting point should be onshore and nearshore, where it's easy and simple. And in the future, as the industry grows, the prices go down, we get more technical experience, then we can look in the offshore. A technology like ours in the offshore can be attached, for example, to oil drilling platforms or to other different structures that are located in the offshore. But for the time being, there's a lot of unused breakwaters everywhere in the world, and we definitely have a huge market before we have to go to the offshore.
Can you imagine supplementing your wave system with solar energy to create a more continuous electricity production?
So we're already started experimenting with installing solar panels on the surface of our floaters. We did it because we really believe that in order to have a 100% renewable energy friendly world, we need to combine all renewable energy sources together, because each of the sources, if it's wind or solar or wave, are dominant during different times of the day. So really, to get a 100% renewable energy friendly world, we need to combine everything together. Of course, the solar panels that are on top of our floaters can generate much less electricity than the energy from the waves, because the density of water is about 832 times greater than density of air. So you can produce much larger electricity amounts with much smaller devices. So each basically solar panel on the floater is about 300 watts maximum. But we can use this energy, for example, for self-consumption, for the automation systems, for the cameras on sites that we're building, and so on.
Let's talk about current projects. Could you elaborate on the performance of the Gibraltar power station?
Of course. So the Gibraltar power station is kind of our first grid-connected proof of concept. And as such, it was really important to us to prove certain elements with the Gibraltar installation. So first one, that we can build cost effectively, because really previous attempts have been built for tens and millions of hundreds of dollars, and we wanted to show that we're not there. The second, we wanted to prove reliability, that even during storm, our equipment can survive. We wanted to prove insurability, which we did, and we wanted to have a chance to do studies that are proving that our technology does not create any environmental impact. On top of that, because many of the wave energy developers are in very early stages, they never got the chance to connect to the grid. So there was a huge question mark on whether wave energy can even connect to the grid safely. So with the Gibraltar power station, we were able to prove that as well, and we're safely connected to the grid since 2016. And now we're doing an independent verification of the Gibraltar results with Dr. Wang Li from the University of Queen Mary. According to our internal engineering report, the Gibraltar power station is able to harness 70% of the available energy in the site, which is an amazing improvement for us, because the year before we were at about 30%. And we're looking to even improve it further through our collaboration with EDF, that is also upgrading our automation and control system, which will enable us to generate even larger electricity amounts here in our Israeli site.
Yes, speaking of that, what is the status of the EDF1 project in Israel. When do you expect it to be up and running?
So we had some delays because of the COVID-19. We needed some licenses from the city in order to do the cement works. So basically we finished all the conversion units, so all the hydraulic, electric works have been finished already. So the power station itself is 100% ready. And now we only have the works on the seaside. So basically reinforcing the breakwater with cement, installing the floaters, and connecting the power station to the grid. We will be starting the grid connection works in 2 weeks already. So that's something that we're very, very excited about. It will be the first time in the history of Israel that wave energy officially connects to the electrical grid. And we're forecasting the power station to be open until mid next year, fully operational.
What is the status of your activities in Portugal? What is the next step there?
So in Portugal, we have established, first of all, in Portugal, we have signed a concession agreement in April of 20 megawatt with APDL, which is the port authority that is responsible for the 4 breakwaters that they gave us the concession for. In order to start the licensing process, we retained a law firm called PLMJ, which has opened for us a local subsidiary because you need to have a local company in order to do the licensing. PLMJ have also found for us a shortened path for licensing of the first 1 megawatt. If you're building up to 1 megawatt, then the concession time, or basically the licensing time, is 6 months. So we already submitted the first documents and started the licensing, and we hope to get the approvals as soon as possible in order to be able to commence actual construction works.
We've been into this earlier, but we're now going over to business and commercialization. And in the IPO of 2019, the company announced that the goal is to construct the first commercial scale wave energy power plants. How are you doing?
So the company, after the IPO, we actually sat with the board of directors and spoke with some of the dominant shareholders of the company in order to decide on the best plan for commercialization, since it's the first time that wave energy is even aspiring to go to commercial scale. And we understood that we raised sufficient funding in the IPO for the construction of 1 commercial scale power station. And we understood that for us, it's better to kind of take the time in order to decide what will be the first site for such construction, because it's actually putting all your efforts and all your financial and human resource into the first one big project. And after a period we took really to decide on the best project to proceed with, we decided on the Portugal project because of the very high wave characteristics in the region and very good structures that we have received there, plus a very significant support from the government that has been researching and investing into wave energy for many, many years. So our goal is, as mentioned previously, and as also mentioned in the quarterly report, is to finish in up to 6 months, finish our EWP EDF1 project, which will be a great preparation for our first commercial scale project. In the same time, finalize the licensing for the Portugal project. And as soon as we get the licensing, enter into construction.
What is the plan for the commercial rollout for the technology?
So the company already holds project pipeline of 254 megawatts. And sometimes I really get asked like, okay, you're just starting your commercial rollout. Why so many PPAs and concession agreements and potential deals? And I explained because we chose kind of a niche market, a very big niche market, but still a niche market of breakwaters and piers and jetties. So we basically want to kind of lock down all the best breakwaters and all the best ports and locations in the world, and to have our kind of strategy for commercial rollout ready in advance. Our goal is really to build the first commercial scale power station, and then according to our discussions with banks, we will have the possibility within 12 to 24 months to hit the first debt financing deal. And really the debt financing is what will enable us to build much more and much faster. Because of course, as probably you understand, equity is the most expensive sort of financing, of course, and it takes very long time because you build one and then raise another equity and then build another. And really the debt financing will enable us to build many projects in parallel and become profitable. So this is kind of the plan of the company.
How will the larger commercial projects be financed?
So the larger commercial projects in our pipeline, we hope and aspire that they can be financed through debt financing in the future, because we believe that wave energy will go in the same path as wind and solar. In the beginning, wind and solar was financed only by equity, and as the industry, became more mature and got more experience and lowered the technological risk, then more really debt givers, banks have started working with them and giving them a certain percentage of the financing. First, they started with 50%, and now it goes up to 80 or 90% debt financing for the projects. So this is how we aspire to fund our projects as well. Right now, because wave energy is of course not bankable at the moment, we finance our operation with equity financing, and we're also applying for different grants in order to leverage on the equity that we've raised.
What is the payback time for a project?
So basically, we know the payback time for a project according to two main factors. The first one is, of course, the wave conditions in the site. The higher the waves, the more energy we produce, and then there is a shorter payback time. And the second thing is, of course, the feed-in tariff that we receive in the location of implementation. Of course, the higher the feed-in tariff, the faster we ROI, return the investment. Sometimes we choose projects that have high feed-in tariffs and the wave resource is lower. Sometimes we choose projects where the wave resource is extremely high and the feed-in tariff is lower, but still the projects are cost efficient. In great locations where we have good feed-in tariff as well as very good wave conditions, the return of investment is in 3 to 6 years.
What does the forecast look like? When will you be profitable?
So we believe that as soon as we're able to get the first debt financing and start constructing multiple power stations, then the wave energy industry and eco-wave power, of course, will become profitable. In the renewable energy, it's key to have multiple yielding assets in order to reach profitability.
When do you think you will reach a competitive cost level?
Being an onshore technology, we're able to bring our CapEx and OpEx, which means construction and operation costs, to a very cost competitive levels. Because of that, as soon as the technology reaches a 20 megawatt scale, the LCOE decreases to about 4 euro cents per kilowatt hour, which is extremely attractive. Given the fact that also the technology, because it's an onshore technology, we're also able to reach such low LCOE at a very early stage in comparable to other offshore technologies.
You have a vast pipeline of projects, but a small organization. How do you intend to execute the pipeline?
So that's actually a very, very good point. You're right that we're a small but a very ambitious organization. And as such, our main way of spreading the technology and of actually being able to supply large-scale projects is through our collaborations with the larger scale organizations. So for example, our joint venture agreement with EDF Renewables IL, a subsidiary of the French National Electrical Company, or just recently we have announced a collaboration agreement with Meridian, which is the largest energy provider in Australia and in New Zealand. So we're doing a lot of this kind of agreements with large-scale electric companies, which have presence in many different countries. And these type of collaborations are helping us actually penetrate those countries without really having a lot of expenses and a lot of human resources, let's call it like that. In addition, we have to remember that we're a technology company and not a construction company. So that's why we can keep ourselves as a relatively small organization. We do the construction through subcontractors, brand names, like for example, we have a strategic collaboration with Siemens. Siemens is doing everything from us, from the generator to the inverter to the actual grid connection. And that of course also helps us to save costs and also use a very quality components that have significant lifespan and guarantees.
In your own opinion, what are the key milestones for the company to achieve a higher acceptance level on the stock market?
So I think that our main difficulty in really Nasdaq Stockholm is mostly communication. I think that being a non-Swedish company, an Israeli company, we don't always know best how to contact our shareholders or how to connect with them or how to explain our plans properly. This is something that we're learning to do through IR activities and through our quarterly reports and press releases and newsletter and social media. And we're basically trying different routes and channels in order to be able to kind of explain ourselves. I think that our path to us is very clear, and we would love our shareholders to also receive some greater understanding of such path. So actually, really the near future plans is to open the power station with EDF, finish the licensing in Portugal, construct the Portugal power station, hit the first debt financing deal, and then start developing the rest of our pipeline. So it's pretty simple, it is pretty clear. We're planning a lot in advance, so everything is done with a lot of thought. And if any of our shareholders, of course, have any questions that you would like to ask, except the questions that we're asking here, then I'm super available, and so is the CFO of the company, and we would love to answer any questions.
The IPO lockup period ends soon. What kind of commitment can shareholders expect from the two main owners and founders of the company, that is yourself and David Leb?
So it's a very important question. Actually, David and we have no intention to sell any of our shares. We have not sold. Of course, we've been in a lockup, but David even bought more shares. He actually reinforced his holding by 1%. So actually, he started with holding 33% and now he's holding 34%. So we're strong believers in the company. We're definitely not planning to sell when the lockup period is over. We believe the company for the very, very long term. Our goal is still to, first of all, prove that we can build commercial scale. We're also planning to uplist the company to the Nasdaq US, as we also notified our shareholders when we were going public in Nasdaq Stockholm. So we have a long way to go, and we're definitely not looking to sell any shares.
Lastly, what will be your focus points in 2021?
So in 2021, as mentioned, we're planning to finally open our second grid-connected power station, which we believe will be a very important and historical moment for the company and for the government of Israel here, because again, it's the first time that wave energy will officially connect to the grid in Israel. We're planning to finish the licensing for the Portuguese project. We're planning to look more seriously into the uplisting of the company to Nasdaq US. And basically, I think 2021 will be a year of keeping our promises to our shareholders and making them happy.
Thank you so much. Inna, do you have any last remarks or any comments?
Yes, I would just like to wish everybody Merry Christmas and Happy Hanukkah and Happy New Year. And I'm looking forward to work more closely with our shareholders and making them happy with their decision to invest in Eco Wave Power.
Inna, thank you so much for your time.
Thank you.